Alright, so this video is going to require us to do a little bit of review from what we've done in the past. And the first thing we have is we have two ordered pairs, and we have to figure out an equation that represents them. So I have 0, 4, and I have 5, 3. And the first thing I have to do is figure out the slope. So this is going down by 1, and this is going up by 5. So my slope is m equals -1 over 5. I now have to figure out my starting point. And this one's kind of easy because of the fact that I have 0 and 4. So this equation will be y equals -1/5 x plus 4. So that's the very first one. So let's just go through and check it. The next one, again, we'll do the same thing where we kind of draw our different order pairs. I'll have 0, 6, and I'll have 2, 0. Go through here. This is going down by 6. This is going up by 2. So I have -3 over 1. That's my slope. And then my starting point is going to be 0, 6. So this will be 3 over 1x plus 6. Again, these are just easy because it has the starting point right here. Now it gets a little trickier with these kind of ones over here. And remember, we have a whole different equation for this. It's pretty easy. So I start out the same way. So I have x and y, and I have 8 and 3, and I have 2 and 6. I have to find the slope. So I have 3. And this is going down by 6, so this is going to be 3 over 6, and it's negative, which equals -1/2. And then I have this equation, y minus y1 equals the slope, and then x minus x1. And all that means is I plug in one of the ordered pairs. So let's just plug in this one here. So I'm going to have my y minus 6 equals -1/2. And then I'll have times x minus 2. And I have to go through and write this again. So I have y minus 6 equals -1/2 x. And then -1/2 times -2 is +1, right? Now I want to get the y by itself, so I have to add 5. So I'll say plus 5 here, plus 5 here. And I'll have y equals -1/2 x plus 6. All right, and if you look here, I actually made an error, and let's try to figure out where the error was. If you look back at my work, where did I make the error? Because this should be +7. And if I look here, I see it right here. There should be a +6, not a +5. So this should be +7. Let's try one more of these. So to go through, let's just try number 6. So I'm going to do my xy, and I'll have 4, 16, and I'll have 2 and 12. So this is going down by 4, and this is going down by 2. So my slope is -4 over -2, or 2 over 1. And now I plug in my y minus y1 equals m times x minus x1, just like I did before. So I'll put y minus, let's use this order pair. So y minus 16 equals my slope, which was 2, times x minus 4. So I distribute, and I'll have y minus 16 equals 2x minus 8. Okay. And then I have to add my 16. Make sure I add the right thing this time. So I have y equals 2x plus 8. So if I go through here, and there we go. Remember, rewatch the video a few times to make sure you get this, because it's really important for this lesson. So what we're going to do is use the data to predict an event. And I have these ordered pairs, and it's going to ask me to go through and actually plot these things out, right? Now, we're going to actually use a different thing. All right, so I'll plot these things out. If I look up here, if I kind of come out, I'll see that it's kind of forming this line, right? Now, something else you can do with Desmos that's pretty cool is I'm going to make an equation, and I'll say y equals mx plus b plus b. So I'm going to add a slider and a b slider. And the reason why I'm doing this is because I want to try to find a starting point first of all. So that's what my b is, right? So if I could actually slide this and look for my starting point, I gotta probably modify this a little bit, right? All right, so when I change my starting thing from -10 to 30, let's say, if I look here, it looks as though it's right about here, right? And I can change my slope a little bit too. So I'm trying to find a line of best fit that goes through all the points. And I'm gonna say maybe, I mean, that's kind of close. It's gotta be in between here, right? I'll just say like right here. So then my equation would be y equals 1x plus 22. And that would be the line of best fit. That's what we're really trying to do with this. So this Desmos program is pretty cool because it allows me to do that. If I go through here, I have some other ordered pairs, so I'll enter these in. All right, so now that I've entered these in, I have to zoom out because it's gonna be much bigger. And then right up here, right? I want to now try to do a different starting point. So I have to start this off, and it looks as though it's gonna start at like right around 300. Let's look here. Let's say like 350. And it's gonna go, so we'll say 0 to 350. So let me go up here and change this one here. So I look here, that looks like it's a pretty good line of best fit, doesn't it? So this would be y equals negative 18x plus 330. And that's going to be my line. Now the reason why we're doing this is because it says predict the number of bats in 3 years from where I'm at. So I started off with year 7, which is kind of hard to see here. This is 7, 197. If I look at 10, year 10, right down this line, it looks like 150. And that's how you use these lines of best fit to determine or predict what you think it might happen. So we're basically doing the kind of the same thing here. Now, once I have this line, I can do a line of best fit. I can actually write an equation for it, can't I? Because now I have just look for 2 ordered pairs. So there's like 1 ordered pair here, which is not a very good number. Let's look to see if there's any good numbers here. So like for instance, like that might be a decent number to use. But really we're looking for whole numbers, right? So like if I can find it. Oh, 10 150 is great. So I'll have 10 150 and 7 197. So let me just do these real fast. So let me go over to my, so if I do 7 150 and 10, what did we say it was? 7 197. That's what it was. 197. So 7 197 and 10 150. If I go through here and find x and y, I just found 2 ordered pairs, right? So this here is going to be 47, and this here is going to be 3. This is going down. So I have negative 47 over 3. And I'll see if there's any way to simplify this. And I just want to show you why those numbers don't line up perfectly, because we have negative 18 here. We'll have to look for points that are on this line, right? So points that are exactly on the line is what I'm looking for. And this 7197 isn't exactly on the line. In fact, it would be like 7.397 in this. So I mean, it's not perfect. So we're looking for ordered pairs that work out perfectly. And I go through the same process that I did before, where I kind of will plug in or find my slope. I'll then go in and I'll have my y minus y1 equals my slope times x minus x1. And I figure this out, and that's how I get the formula that I actually get for my equation. Now, a few of these will be much easier than other ones. So like this might be a good line or an equation because the numbers look like they're going to work a little bit better. So let's try this one. All right, so I plug these numbers in, and let's just zoom out real fast. So if we look here, it looks like it's down here somewhere. And if I look for a line of best fit, let's first of all start off with my intercept. It's going to start a little bit lower. And it looks like it's a positive slope, right? So maybe my line of best fit's right around here. I'd say like right about here. Now we have to zoom in and look for 2 places where this is actually on the line. So one point is 1 and 4. That looks like it's on my new line, right? So I'm going to write down 1 and 4. Let's write this down. And the other point, if I look here, looks like 1.5 and 6. Any other points? 0, 0. That works out well. So if I do 0, 0. Well, now I'm going to plug this into my table. And I have my 1, 4 and 0, 0. I look for my ordered pair. That's going to be -4. That's going to be -1. So that would be 4 over 1. So it looks like my slope, and I have my starting point already, which is great. So it'd be y equals 4 over 1x plus 0. And that looks like my line of best fit when I go through here. And we're going to have different numbers. They have 0.5, but plus 0 is about the same. So then it says how much for 10 bananas? Well, if I plug in a 10 here, that's about 40. They have 40.5. So that's how we really use this. We're going to play around with Desmos through this lesson. We'll be doing some of this as well. I invite you to go to Desmos, try to plug these numbers in, find the line of best fit. That's really what the focus of the lesson is today, just playing around and trying to determine what line would help us predict other